Today we're going to look at interpreting our product moment correlation coefficient, our PMCC, which we also call R, in order to determine whether the value of R implies that we have a positive correlation and negative correlation, or whether in fact there's no correlation there. It's very, very, very rare that you would actually get an R value of 0. So if I got an R value of 0.1, does that tell me there's positive correlation or not? Is it only by chance that we happen to see that very, very small number for our PMCC? Is there actually no correlation? And the critical values that we use to decide whether there is 0 correlation or whether there is evidence of some positive or negative correlation, those values vary depending on the sample size. So if you've got a small sample size, then you would be able to get quite a high PMCC out of that data without there even being any correlation actually existing. So this table shows us our critical values. So if we had a PMCC below these values, then we would be confident that there was 0 correlation in that data. So for example, if I had 20 pieces of data, I would be looking at this row here. You can ignore the right hand side of the table for now, that's to do with Spearman's rank correlation coefficient. The left hand side is the product moment coefficient, the PMCC. So if we're looking at a sample size of 20, if I had measured my PMCC, I'd calculated it to be 0.4, and I wanted to check at the 2.5% significance level whether that implied there was actually positive correlation. Well, at the 2.5% significance level, 0.4 is less than this critical value. So that would imply that there is zero correlation. I would say that there is evidence of 0 correlation because my product moment correlation coefficient is less than the critical value. It's closer to 0 than this value, which we use as our cut-off point. If I was testing my 0.4 at the 10% significance level, so at a higher confidence level, then my PMCC is greater than the critical value, so that would show there is evidence of positive correlation. So that would dismiss that idea of 0 correlation. If I had a bigger sample, it would reduce my critical values. If I was working with something that had a negative product moment correlation coefficient, then I would use the same table but with negative values. So if I use a sample size of 30, and let's say that I had calculated my PMCC to be minus 0.3, then if I was working at the 5% confidence level, then that would be evidence of 0 correlation because it's less than the critical value. But if I was working at a 10% confidence level, then it would not imply 0 correlation because it is greater than this critical value. So it depends on the confidence level as to whether we can be confident of 0 correlation or not. Let's have a look at some examples of putting this into use. So we start off using the same notation as we did when we were hypothesis testing. This time we can use 2 different sets of notation. R for the PMCC of the sample and P for the PMCC of the whole population. Obviously, if we wanted to test correlation of the whole population, the best way to do it would be to collect data from the whole population, and then we would clearly see whether there's correlation or not from that PMCC. However, that's not always logistically possible. We've got time and expense constraints, so we often use a sample, and the PMCC of the sample is then what we test against those critical values. We're not 100% confident in it because it's only PMCC of a sample rather than the whole population. So we're going to write down our hypotheses. Our null hypothesis is that there is zero correlation, and our alternative hypothesis, our alternate hypothesis is either that we've got positive correlation, or that we've got negative correlation, or that we've got no correlation. If we're testing for no correlation, that's a two-tailed test, because we're considering whether it's positive or negative. We're testing it at both ends. If it's a one-tailed test, then it's just we're checking if it's positive or if it's negative. Remember, if we're working with a two-tailed test, so if we're just assessing whether there is no correlation versus some correlation of either a positive or a negative nature, then we need to half the significance level in our working. Let's have a look at an example. A scientist takes 30 observations of the masses of two reactants in an experiment, and she calculates a PMCC of R equals minus 0.45. The scientist concludes that there is no correlation between the masses of the two reactants, and we need to test this at the 10% level of significance. So let's state the hypotheses. The null hypothesis is always that the PMCC of the whole population is 0. The alternate hypothesis is that that is not 0 in this case. We're just checking whether there is correlation. So we've got 10% level of significance, but it's a two-tailed test, so we're going to read the 5% significance level critical value. So she had 30 observations, so the 5% level, our critical value is 0.3061. So our critical values are plus and minus 0.3061 because we're checking for positive and negative. Now minus 0.45 is further from 0 than our critical value, therefore there is evidence of correlation. So we just need to jot that down. And then we need to make sure that we state what that means in the context. And in this case, the scientist's claim was that there was no correlation, but we can say the scientist's claim is not supported. Okay, let's have a look at another example. So in this example, we're looking at some data from the large data set about the maximum gust and the maximum relative humidity in Leemin for 8 days in May 2015. So in this case, we haven't been told the PMCC. We're going to get some easy marks for working it out. So remember, on your calculator, you need to be in mode 6 of statistics, and then you need to select the data type y equals a plus bx because we're looking at linear correlation here. So then you need to enter your data, which I have already done, and then press cancel, and then option number 3 for regression calculations, and there's our R, 0.0724. So part B is to test whether there is evidence of positive correlation. So this time our null hypothesis, as always, is that there is zero correlation, and our alternate hypothesis is that there is positive correlation. So we've got a one-tailed test this time. We've got a sample of 8 pieces of data, and we're testing at the 10% significance level. So 10% significance level for a sample size of 8 is 0.5067. So that's our critical value. So our product moment correlation coefficient for the data, RR, is less than that critical value. So that means we accept the null hypothesis and there is evidence of zero correlation. So actually, if I go back to that first example, I've missed a step here, as I should have stated that we were rejecting the null hypothesis because our PMCC was further from zero than the critical value. Make sure you do state whether you're accepting H0 or rejecting it or accepting H1. Okay, I'll leave you to get on with the questions from the worksheet. Remember to ask for help if you need it.